Yes, we are going to discuss 10.4 today. Let me present my screen. Ten point four deals with areas and arc lengths in polar coordinates. You see, this area bounded by the function r is equal to f theta. In polar coordinate, you know, just like x and y in Cartesian coordinate system, we have r and theta in the polar coordinate system. So r is equal to f theta represents a curve. So that curve is drawn here. Theta is equal to alpha and theta is equal to beta. This is theta is equal to alpha and theta is equal to beta. So area bounded by r is equal to f theta. Theta varies from alpha to beta is given here, the shaded region that is given by area is equal to and integral alpha to beta 1/2 r square d theta. Integral alpha to beta 1/2 r square d theta. You will learn the derivation of this in your calculus 3 only. The arc length means the length of this curve. Arc length is equal to alpha to beta, integral alpha to beta, square root of r square plus dr over d theta, the whole square d theta. That is integral alpha to beta, square root of r square plus dr over d theta, the whole square d theta. Now let us start with question number 2 from the textbook. Find the area specified by r is equal to cos theta, 0 less than or equal to theta less than or equal to pi over 6. And formula is area is equal to alpha to beta 1/2 r square d theta. Here r is cos theta, so it is 1/2 cos square theta d theta. That is 1/2 is pulled out 1/2 times. You use the power reducing formula. Integral 0 to pi over 6, 1 plus cos 2 theta over 2. Cos square theta is 1 plus cos 2 theta over 2. That is equal to 1 over 4 times theta plus theta. Under derivative of 1 is theta plus under derivative of cos 2 theta is sin 2 theta over 2. So 2, 1, already there is a 1/2 and there is another 2 in the denominator, that becomes 1/4. So it is 1/4 times theta plus sin 2 theta over 2, 0 to pi over 6. Now substitute the limits. When you substitute the upper limit, it becomes 1/4 times theta is pi over 6 plus 1/2 times 2 theta means 2 times pi over 6. 2 times pi over 6 is pi over 3. So this is sin pi over 3 minus. When you substitute the lower limit, you get 1/4 times 0 plus sin 0. Sin 0 is 0. So the lower limit gives a 0. And this is sin pi over 3. Pi over 3. Sin pi over 3 is square root of 3 over 2. So the answer is 1/4 times pi over 6 plus 1/2 times square root of 3 over 2 on simplification. Or if you distribute that 1/4, you get pi over 24 plus square root of 3 over 16. Question number 4 from the textbook. R is equal to 1 over theta. Theta varies from pi over 2 to 2 pi. Just application of the formula. Area is equal to integral alpha to beta means pi over 2 to 2 pi 1/2 r square d theta. That is pi over integral pi over 2 to 2 pi 1/2 times r square is 1 over theta square d theta. That is equal to 1/2 times 1 over theta square is theta to the negative 2. So under derivative is theta to the negative 2 plus 1 over negative 2 plus 1. That is theta to the negative 1 over negative 1. Pi over 2 to 2 pi. That is equal to negative 1 over 2 theta from pi over 2 pi, because there is a negative 1 here. So negative 1 means the whole expression is negative. theta to the negative 1 is 1 over theta. So negative 1 over 2 theta. Theta varies from pi over 2 to 2 pi. That now substitute the limit. When you substitute the upper limit, it becomes negative 1 over 2 times 2 pi. That is negative 1 over 4 pi minus. Now substitute the lower limit, negative 1 over 2 times pi over 2. That is negative 1 over pi. And 2 negatives makes a positive. So this is a positive 1 over pi. So 1 over pi minus 1 over 4 pi. And you need a common denominator. So multiply by 4 over 4. So it becomes 4 over 4 pi minus 1 over 4 pi, which is 4 minus 1, that is 3. 3 divided by 4 pi, and that is the answer. Question number 6. R is equal to 2 plus cos theta, pi over 2 less than or equal to theta, less than or equal to pi. So here a little bit algebra is involved, so I'm going to simplify 1/2 r square first. 1/2 r square is equal to 1/2 times r is 2 plus cos theta, so 2 plus cos theta the whole square, that is 1/2 times 4 plus 4 cos theta plus cos square theta. If you don't remember the formula for a plus b the whole square, which is a square plus 2ab plus b square. If you do not remember that, then you write 2 plus cos theta times 2 plus cos theta. FOIL and combine like terms, you get this. So that is 1/2 times 4 plus 4 cos theta plus power reducing formula. Cos square theta is 1 plus cos 2 theta over 2. And that is, this is a plus 1/2. So you have a 4 here. 4 plus 1/2 is 4.5. That is 9 over 2 plus 4 cos theta plus 1/2. That is cos 2 theta over 2. That means 1/2 cos 2 theta. And now you are ready to integrate. Area is integral pi over 2 to pi 1/2 r square dr. That is equal to integral pi over 2 to pi 1/2 times 9 over 2 plus 4 cos theta plus 1/2 cos 2 theta d theta. And now integrate. 1/2 is pulled out. 9 over 2 theta plus 4 sine theta, and the derivative of cos theta is sine theta, plus 1/2 times sine 2 theta over 2. And now substitute the limits. 1/2 times upper limit 9 over 2 times pi plus sine pi, 4 sine pi, that is 0. 4 1/2 sine 1/4 sine 4 pi. I mean 2 pi, that also is 0 minus. Now substitute the lower limit, that is 1/2 times 9 over 2 times pi over 2 plus 4 times sine pi over 2, which is 1. So it is 4 times 1 plus 1/4 times sine 2 times pi over 2, which is sine pi, that is 0. And so the answer is, this is 9 pi over 4 minus 9 pi over 8, 2 times 2 times 2, 9 pi over 8 minus 2. How do you get a 2? When you distribute this 1/2 to 4. Minus 1/2 times 4 is minus 2. And now you simplify. You need a common denominator here. Multiply by a 2 over 2. So you get 18 pi over 8 minus 9 pi over 8, which is 9 pi over 8 minus 2. And that is the answer. 9 pi over 8 minus 2. Number 8. R is equal to square root of natural log of theta. Theta varies from 1 to 2 pi. Area is equal to 1 to 2 pi 1/2 r square d theta. That 1/2 is pulled out. 1/2 times integral 1 to 2 pi r square is natural log of theta. I wrote a natural log theta times 1 d theta in order to apply the integration by parts. So I have done the integration by parts here. F is natural log of theta. G prime is 1. Derivative of natural log of theta is 1 over theta. And the derivative of 1 is theta. And now F times G. that is theta times natural log theta minus integral f prime g. So that is 1 over theta times theta d theta, and that is 1/2 times theta natural log theta minus, this is a 1 and the derivative of 1 is theta. So theta natural log theta minus theta from 1 to 2 pi, that is equal to 1/2 times, you substitute the upper limit, you get 1/2 times 2 pi times natural log 2 pi minus 2 pi minus 1/2 times 1 times natural log 1 minus 1. Natural log 1 is 0. So this is pi times, when you distribute that 2, you get 2 cancels, pi times natural log 2 pi minus pi plus 1/2. This is 0. Natural log 1 is 0. So negative 1/2 times negative 1, which is plus 1. So pi times natural log 2 pi minus pi plus 1/2. Number 10. R is equal to 1 minus sine theta. The value of boundary values are not given. If it is not given, usually it is 0 to 2 pi. So let us see how the graph looks like. R is equal to 1 minus sine theta. One minus sine theta, window 0 to 2 pi. So that is the graph. Okay, so 0 to 2 pi is one complete rotation. Okay, since it is a little difficult, I mean the algebra part is a little difficult, you first calculate 1/2 r square, because formula is integral alpha to beta 1/2 r square d theta. So first you calculate 1/2 r square, that is 1/2 times 1 minus sine theta the whole square, that is 1/2 times FOIL 1 minus 2 sine theta plus sine square theta. Again apply the power reducing formula. So 1/2 times 1 minus 2 sine theta plus 1 minus cos 2 theta over 2. Sine square theta is 1 minus cos 2 theta over 2. That is 1/2 times, here 1/2, 1 plus 1/2 is 3/2. 1.5, which is 3 over 2. So 1/2 times 3 over 2 minus 2 sine theta minus 1/2 cos 2 theta. Now you integrate. Area is integral 0 to 2 pi 1/2 r square dr, that is 0 to 2 pi 1/2 times 3 over 2 minus 2 sine theta minus 1/2 cos 2 theta d theta. Pull out the 1/2 times 3 over 2 theta plus 2 cos theta y, and the derivative of sine theta is negative cos theta. So the two negatives makes it a positive, minus under derivative of cos 2 theta minus 1/2 times under derivative of cos 2 theta is sine 2 theta over 2, 0 to 2 pi. Now substitute the limits. 1/2 times 3 over 2 times 2 pi plus 2 times cos 2 pi, which is a 1, minus sine 4 pi, which is 0. 1/2 times sine 4, 1/4 times sine 4 pi, that is 0. Now substitute the lower limit. 1/2 times 3 over 2 times 0, so that is 0, plus 2 cos 0, cos 0 is 1, so that is 2 times 1, minus 1/4 times sine 0, sine 0 is 0. And now simplify it. This is 2 cancels, 3 over 2 pi plus 2 plus 1. So if you distribute 1/2, you get 3 over 2 pi plus 1 minus 1. here minus 1 is there. So plus 1 minus 1 cancels. So the answer is 3 pi over 2. This is question number 4 from the 14 from the textbook. R is equal to 3 minus 2 cos 4 theta. So let us draw that graph and see how it looks like. 3 minus 2 cos 4 theta. We have to change the window for x and y. Think negative. This is 1, 2, 3, 4. Negative 6 will be okay. So negative 6 to 6. Negative 6 to 6. So here is the graph. And you see, because of symmetry, you can find the area of one of these and then find the multiply that by appropriate number. So here, first before writing I did not do that. I have taken from 0 to 2 pi itself. The other one is a way to do it. Okay, so here also there is a little algebra involved. So 1/2 r square is equal to 1/2 times 3 minus 2 cos 4 theta, the whole square. That is 1/2 times FOIL 9 minus 12 cos 4 theta, 2 times 3, 4, 12 cos 4 theta plus 4 cos square 4 theta. That is 1/2 times 9 minus 12 cos 4 theta plus 4 times. Apply the power reducing formula. Cos square theta is 1 plus cos 2 theta over 2. So the angle must be doubled. Here it is 4 theta. So it must be doubled. It becomes 8 theta. So 4 times 1 plus cos 8 theta divided by 2. And that is 1/2 times 9 minus 12 cos 4 theta plus 2. When you cancel this, you get a 2. And 2 times 1 is 2. 2 times cos 8 theta. So 2 cancels with the 4 and then you distribute that 2. You get 2 plus 2 cos 8 theta. That is equal to 1/2 times. Yeah, we discussed that. Next, that is equal to 1/2 times 11, 9 plus 2. 9 plus 2, 11, minus 12 cos 4 theta plus 2 cos 8 theta. Now we are ready to integrate. Area is equal to integral 0 to 2 pi. Since the limits for theta are not given, you have to assume that it is 0 to 2 pi. 1/2 times r square dr, that is equal to integral 0 to 2 pi, 1/2 times 11 minus 12 cos 4 theta plus 2 cos 8 theta d theta. That is 1/2 times 11 theta minus 12 times sine 4 theta over 4 plus 2 times sine 8 theta over 8 from 0 to 2 pi. That is 1/2 times upper limit 2 pi, 11 times 2 pi minus 12 over 4 times sine 8 pi, which is 0. Here also sine 16 pi, that also is 0, minus lower limit is completely 0. So the answer is 1/2 times 22 pi, that is 11 pi. So the answer is 11 pi. And here number 18. Yes, so again, let us draw this and see. r square is equal to, oh, it is r square. Anyhow, you don't have to draw. If you want to draw, you have to draw two curves. R is equal to 2 times square root of cos 2 theta, and r is equal to negative 2 times cos 2 theta. So it's not necessary. So the graph looks like this. Oh, okay. We want to make sure that the graph looks like this. R is equal to 2 times square root of 2 theta. R is equal to 2 times cos square root of cosine 2 theta. Let us see how the graph looks like. Oh yeah, complete. It is completely there. So that is 0 to 2 pi. So let us change the window from 0 to negative 2 to negative 2 to 2. Yes, so that is the graph. Okay, and now we divide this into 4 equal parts. Actually, some parts are not visible. The area is just like this. So we are going to divide this into 4 equal parts. And this on the x-axis, theta is 0. So theta is 0 means r is 2. So that is why we have the 2 here, but that doesn't affect it. But theta is equal to pi over 4. What is r? R is 0. 4 times cosine 2 times pi over 4. That is cosine pi over 2, which is 0. So here, from theta is equal to 0 when theta increases, and when theta is equal to pi over 4, it comes here. That means that shaded region lies between theta is equal to 0 and theta is equal to pi over 4. So you first to find the area of that shaded region and then multiply that by 4. So that is the total area. So area of one loop is 2 times. Question is area of one loop, not the whole area. So it is 2 times the shaded region, shaded area. That is 2 times integral 0 to pi over 4, 1/2 times r square dr. The 2 and 1/2 cancels, so that becomes r square. R square is 4 cos 2 theta. So these 2 cancels. Pull out the 4, you have 4. And the derivative of cos 2 theta is sin 2 theta over 2. And that is substitute the limit. This is 2 times, 2 goes into 4, 2 times. Upper limit, sine 2 times pi over 4, that is sine pi over 2, minus 0, because lower limit is 0. Sine pi over 2 is 1. So 2 times 1, the answer is 2. Remember the question, I did not completely write the question. I did not write the question completely. So the question is, for this curve, find the area of one loop. If you are asked to find the area of both, the total area, you have to multiply this by 2. Number 20. R is equal to 2 sine phi theta, and you have to figure out the limits for theta. See, let us draw it. R is equal to 2 sine phi theta. 2 sine phi theta. And here the question is, find the area of one loop. So we are concentrating on this loop. I did not draw the figure, but this is the figure. And here we are concentrating on one loop. And for that, for this one particular loop, we have to see what the limits for theta are. For that, you set r is equal to 0. So set r is equal to 0. Because r is equal to 0 is the origin. So theta varies from 0 to, when it reaches here, you have to figure out what the value of theta is. So set r is equal to 0. R is equal to 0 implies sine phi theta. 2 sine phi theta is 0 means sine phi theta is 0. So phi theta is equal to either 0 or pi. These are the first two values of phi theta. So theta is equal to 0 over 5 or pi over 5. So theta varies from 0 and pi over 5. This is for the first loop. That is for the first loop. And then area is integral 0 to pi over 5, 1/2 times r square dr. That is integral 0 to pi over 5, 1/2 times 4 sine square phi theta d theta. That is a 4 over 2 that is pulled out. Then you use the power reducing formula. Integral 0 to pi over 5, 1 minus cos 10 theta. The angle must be doubled. Cos 1 minus cos 10 theta whole divided by 2. And those 2, 2 times 2 is 4 and 4 over 4 is a 1. So no number is outside, just 1. Integrate, antiderivative of 1 is theta, antiderivative of cosine 10 theta is sine 10 theta over 10 because this 2 is already gone. So that is sine 10 theta over 10. Substitute the limit. When you substitute the upper limit, you get pi over 5 minus sine 10 times pi over 5. That is sine 2 pi, which is 0. And when you substitute the lower limit, you get 0 minus 0. That is again 0. So the final answer is pi over 5. Find the area of the region inside the first curve and outside the second curve. First curve is r is equal to 1 minus sine theta. Let us draw those. First curve is r is equal to 1 minus sine theta. That is the first curve. And now the second curve is r is equal to 1. That is a circle. So the question is find the area of the region inside the first curve and outside the second. That means the shaded region here. So the first curve is here, second curve is that circle. So it is in between these two. So you have to figure out, and it's clear now here. This is pi is equal to theta is equal to pi because here is theta is 0, pi over 2. This is pi, and here it is 0 or which is the same as 2 pi. So theta varies from 0 to 2 pi. Pi to 2 pi, not 0 to pi to 2 pi. But you have to find the difference. So shaded region and is equal to outer area minus inner area. So the outer area minus inner area. And that means pi times pi to 2 pi, 1/2 times outer area is 1 minus sine theta the whole square d theta. By outer area we mean this area of that cardioid. Then you have to subtract whatever is here. That is actually area in the circle. So 1/2 times 1 minus sine theta the whole square times minus pi to 2 pi 1/2 times 1 square d theta. 1/2 times 1/2 times 1 square d theta. So that is this area. That is inside the circle. Okay. So a little bit algebra is here. So pi to 2 pi, 1/2 times, FOIL this, 1 minus 2 sine theta plus sine square theta minus 1/2 times theta d theta. This is a 1. So it is theta d theta. And that is equal to integral pi to 2 pi, 1/2 times 1 minus 2 sine theta plus sine square theta. Sine square theta is double angle, power reducing formula, that is 1 minus cos 2 theta over 2 minus 1 over 2 times 2 pi minus pi, that is 1 half times pi to 2 pi, 3 over 2. Here is a plus 1 half. 1 plus 1 half is 3 over 2 minus 2 sine theta minus 1 half cos 2 theta d theta minus pi over 2. Then that is equal to 1 half times pi to 2 pi. 1 half is pulled out, pi to 2 pi, 3 over 2, that is 1 plus 1 half, 3 over 2, minus 2 sine theta, again minus 1 half times cos 2 theta d theta minus 1 half pi. That is equal to 1 half times 3 over 2 theta plus 2 cos theta, and the derivative of sine theta is minus cos theta, so it becomes plus minus 1 half times sine 2 theta over 2 from pi to 2 pi minus pi over 2. That is 1 half times, you are substituting the limit, 3 over 2 times upper limit minus lower limit plus 2 times cos 2 pi minus cos pi minus 1 half times sine 2 pi, sine 4 pi minus sine 2 pi. So that is 0 minus pi over 2. That is equal to 1 half times 3. This is 1 pi. So that is 3 pi over 2 plus 2 times 1. Cos 2 pi is 1. Cos pi is negative 1. So 1 minus negative 1 minus pi over 2. That is 1 half times 3 pi over 2 plus 4, because 1 minus negative 1 is a 2. 2 2s are 4 minus pi over 2, and you distribute that 1 half, you get 3 pi over 4 plus 2 minus pi over 2. Now combine 3 pi over 4 minus pi over 2. So that is pi over 2 means 2 pi over 4. So 3 pi over 4 minus 2 pi over 4, which is pi over 4 plus 2, and that is the answer. I know that question was not very easy. Number 28 is a very similar one. Here also algebra is involved. So R is equal to, you are asked to find the area between the two curves. Area bounded by the two curves. So let us draw the graph and see. First one, R is equal to 3 sine theta. Three sine theta. R is equal to 3 sine theta is there. So we have to change the window, at least the upper y value. This is R is equal to 3 sine theta. Now R is equal to 2 minus sine theta. So there it is. And so here is the graph. It is two circles. And no, first one is a circle, second one is a cardioid. So the second one, yeah, let us change the window and say. That's a circle. And the other one is a cardioid. And so you are asked to find the area inside the first one and outside the second one. The area inside the first curve and outside the second curve. So we are asked to find the shaded area. So the shaded area is, you have to figure out what this number is. This value of theta at this point, because shaded area lies between this line and the y-axis. So y-axis is pi over 2. Theta is equal to pi over 2. You have to figure out what the angle is here. For that, you set 3 sine theta is equal to 2 minus sine theta. In order to find the point of intersection, you have to solve the two equations. So you set the two equations equal to each other. Now add a sine theta on both sides. You get 4 sine theta is equal to 2. That is, sine theta is equal to 1 half. Sine theta is equal to 1 half means theta is equal to either pi over 6 or 5 pi over 6. So this is 5 pi over 6. We don't need it. Of course, you can use that, but in this case, I applied the symmetry here. So this part is pi over 6 to pi over 2, and then you double it. That's it. So area is equal to 2 times the shaded area. That is 2 times integral pi over 6 to pi over 2, outer area minus inner area. Outer area is here, that is 3 sine theta, the whole square. R is 3 sine theta on the outer square, minus 1 half times inner area, that is 2 minus sine theta, the whole square. It is from pi over 6 to pi over 2. And now a little algebra is involved, so that is equal to 2 times integral 9 sine square theta minus distribute that. What happens? There is oh yeah, 2 cancels here. That is the reason. So here is a 1 half, here is a 1 half, and there is a 2 outside. So these two 1 halves cancel. So you get 9 sine square theta minus, foil this because this 1 half is already gone, 4 minus 4 sine theta plus sine square theta d theta. Now you distribute, that is integral pi over 6 to pi over 2, 9 sine square theta minus 4 plus 4 sine theta minus sine square theta d theta, that is equal to pi over 6 to pi over 2, 8 sine square theta minus 4, because 9 sine square theta minus 1 sine square theta is 8 sine square theta, minus 4 plus 4 sine theta. Now you use the power reducing formula. Sine square theta is 1 minus cos 2 theta over 2. So that is integral pi over 6 to pi over 2, 8 times 1 minus cos 2 theta divided by 2. And 2 cancels with 8, leaving a 4 there, minus 4, this minus 4, plus 4 sine theta d theta. Now again, one more simplification. You have a 4 times 1, that's a 4, that cancels with this 4. So when you distribute, you get 4 minus 4 cos 2 theta, because 2 cancels with 8, leaving a 4 there. When you distribute that 4, you get 4 minus 4 cos 2 theta, and there is a minus 4 plus 4 sine theta d theta. 4 cancels. So final answer is, you pull out a minus 4 times integral pi over 6 to pi over 2 cos 2 theta minus sine theta, because negative 4 is pulled out. And now integrate negative 4 times integral of cos 2 theta is sine 2 theta over 2. Integral of sine theta is negative cos theta. So 2 negatives makes a positive. So it is negative 4 times sine 2 theta over 2 plus cos theta pi over 6 to pi over 2. Now substitute the limit. When you substitute the upper limit, you get negative 4 times upper limit sine 2 times pi over 2. That is sine pi over 2. That is 0. Plus cos pi over 2. Cos pi over 2 is 0. Minus, now you substitute the lower limit. Sine 1 half times sine 2 times pi over 6. That is pi over 3. Plus cosine pi over 6. Theta is pi over 6. That is negative 4 times negative. You are distributing this negative 1 half times square root of 3 over 2 minus square root of 3 over 2, because sine pi over 3 is square root of 3 over 2. That's the same as cosine pi over 6. And so this is equal to, distribute the negative 4, you get square root of 3 because the 4 cancels, plus 2 square root of 3, 3 square root of 3 plus 2 square root of 3 is equal to 3 times square root of 3. Okay, now here is another question. Find the area inside both squares. So here the question is slightly different. Previous question was area inside the first curve and outside the second curve. Here the question is area inside both the curves. Let us draw the curves. Y is equal to, clear. First one is 1 plus cos theta. 1 plus cos theta. Let us see how it looks like. That is again a cardioid like this. Then 1 minus cos theta. It is going to be on the other side. Y is equal to 1 minus cos theta. Yeah, I'm going to change the window to make it more clear. So inside both the curves means see these 4 segments. So here is 1, 2, 3, 4. So my strategy is I'm going to find the area of one of them and then multiply by 4. So here this shaded area is completely inside the first quadrant. Theta is equal to 0 and theta is equal to pi over 2. So if you want to find that shaded area, your variation of theta is from 0 to pi over 2. And there are 4 such areas. Therefore, you have to multiply shaded area by 4. So area is equal to 4 times the shaded area. That is 4 times integral 0 to pi over 2, 1/2 times r square d theta. And this curve, see this is the curve. It is bounded by only one curve. Even though both of them are given there, the shaded area is bounded by only one curve and the y-axis. So y-axis theta is pi over 2. So upper limit is going to be, upper limit is pi over 2. So but what is the equation of this cup? That is 1 minus cos theta. So 1 plus cos theta is not a part of the shaded area. So it is 1 minus cos theta. R is equal to 1 minus cos theta. So 4 times 1/2 is a 2 pulled out, 0 to pi over 2, 1 minus cos theta the whole square, because R is 1 minus cos theta. FOIL, that is 2 times integral 0 to pi over 2, 1 minus 2 cos theta plus cos square theta, and apply power reducing formula. That is 2 times integral 0 to pi over 2, 1 minus 2 cos theta plus 1 plus cos 2 theta over 2. There is a 1/2 here. So 1 plus 1/2 is a 3/2. So it becomes 2 times integral 0 to pi over 2, 3/2 minus 2 cos theta plus 1/2 cos 2 theta. Now integrate, you get 2 times 3/2 times theta minus 2 sine theta plus 1/2 times sine 2 theta over 2. And that is equal to, substitute the upper limit, you get 2 times 3 over 2 times pi over 2 minus 2 sine pi over 2 plus 4 sine pi, 1 over 4 sine pi, minus, when you substitute the lower limit, all the terms are zeros. 3 over 2 times 0 is 0, sine 0 is 0, sine 2 times 0 is 0. So the lower limit produces a 0. Now it's rest is a matter of distributing this. So 2 times, one of the 2's cancels, you get a 3 pi over 2 minus 2 times minus 2. Sine pi over 2 is 1. So 2 times minus 2, that's minus 4 times 1, sine pi is 0. So that is 3 pi over 2 minus 4 is the answer. And now the next question is a made up question. It's not from the textbook. The question is find the length of the curve r is equal to 2 cos theta. Find the length of the curve r is equal to 2 cos theta. So here there is a very important fact that you have to remember. Let us draw this graph. R is equal to 2 cos theta. Two cos theta. That is a circle, but there is a big problem. That problem is very, very difficult to identify that. So that problem is, look at the window. Here it varies from 0 to 2 pi. I'm going to write it first 0 to pi over 2. That means 1/2 of that. And then y is equal to, window 0 to pi. Let us use a pi. You get the whole circle. So that means theta varies from 0 to pi only if you want to find the whole area. Or you may find the area of the upper half, multiply by 2. So upper half is 0 to pi over 2. Okay, so yes, we are finding the upper half. So find the length of the curve r is equal to 2 cos theta. And so remember theta varies from 0 to pi. But if it is 0 to pi over 2, it is the upper half. So we are going to find out the upper half first. R is equal to 2 cos theta. Dr over d theta is negative 2 sine theta. So square root of r square plus dr over theta the whole square is equal to square root of 4 cos square theta plus negative 2 sine theta the whole square. That is square root of 4 cos square theta plus 4 sine square theta. Pull out the 4. Square root of 4 times cos square theta plus sine square theta. Cos square theta plus sine square theta is 1. So it is square root of 4, which is 2. So that expression is, the value is 2. Now you use the formula. Length of the upper half. Upper half, theta varies from 0 to pi over 2. So length of the upper half, that is 0 to pi over 2 square root of r square plus dr over d theta the whole square. D theta, that is the formula. And now that square root of r square plus dr over d theta the whole square is 2. So that is integral 0 to pi over 2 d theta. That is 2 times theta, which is equal to 0 to 2 theta varies from 0 to pi over 2. So 2 times pi over 2. That is, answer is pi. This is the upper part alone. Therefore, the total length is 2 times pi, 2 pi. You can verify this. This is a circle with radius 1. That's a circle with radius 1. And therefore, 2 cos theta. So it's a circle with radius 1. So circumference is 2 pi r. That is 2 pi times 1. So our answer is right. It is 2 pi. Then, next. R is equal to, this is question number 46 from the textbook. R is equal to theta, 5 to the power of theta, 0 less than or equal to theta, less than or equal to 2 pi. That is given in the problem. So you don't need to graph it. Find the arc length. Direct application of the formula. R is equal to theta to the 5 to the power of theta. Therefore, dr over d theta is 5 to the power of theta times natural log of 5. Recall that formula. Derivative of b to the power of x is b to the power of x times natural log of b. So this is 5 to the power of theta times natural log of 5. So r square plus dr over d theta the whole square is 5 to the theta the whole square. That is 5 to the 2 theta plus phi to the theta the whole square, that is phi to the 2 theta, times natural log of phi the whole square. Pull out phi to the 2 theta. So that is phi to the 2 theta times 1 plus natural log of phi the whole square. So the square root of r square plus dr over d theta the whole square is equal to phi to the theta times square root of 1 plus natural log of phi the whole square. But the convenience is this is a constant, so that will not affect it. So the simplified value of square root of r square plus dr over d theta the whole square is phi to the theta times square root of phi to the 2 theta is phi to the theta. The times square root of 1 plus natural log of phi the whole square. Therefore, the arc length is integral 0 to 2 pi square root of r square plus dr over d theta the whole square d theta, and that is equal to integral 0 to 2 pi phi to the theta times square root of 1 plus natural log of phi the whole square. That may be pulled out because that is a constant. So that is square root of 1 plus natural log of phi the whole square times, and a derivative of phi to the theta is phi to the theta divided by natural log of phi. And now substitute the limit. Limit varies from 0 to 2 pi. So square root of 1 plus natural log of phi the whole square divided by natural log of phi times upper limit theta to the phi to the 2 pi minus lower limit phi to the 0, which is 1. So this is the answer. The answer is square root of 1 plus natural log of phi the whole square over natural log of phi times phi to the 2 pi minus 1. The last question, question number 48. Here again, the variation is 0 to 2 pi. So r is equal to 2 times 1 plus cos theta. Therefore, dr over d theta is negative 2 sine theta. So r square plus dr over d theta the whole square is 4 times 1 plus cos theta the whole square plus 4 sine square theta. Distribute, pull out the 4 and then FOIL this. 4 times 1 plus 2 cos theta plus cos square theta plus sine square theta, because 4 is already pulled out, and cos square theta plus sine square theta is a 1. So that is 4 times 1 plus 2 cos theta plus 1, and that is a 2. So 4 times 2 plus 2 cos theta, 1 plus 1 is 2. Pull out another 2, so it becomes 4 times 2, which is 8. 8 times 1 plus cos theta. And you have to find the square root of that. So you use a trig identity in order to find the convenient square root. Otherwise, it is not easy to integrate. 1 plus cos theta is 2 cos square theta over 2. 1 plus cos theta is 2 cos square theta over 2. There is a similar result for sine square, that is 1 minus cos theta is 2 sine square theta over 2. So in this case, I used that identity. That identity is 1 plus cos theta is 2 times cos square theta over 2. So this is 8 times 2, 16 cos square theta over 2. Therefore, square root of r square plus dr over d theta the whole square is square root of 16 cos square theta over 2, which is 4 times cos theta over 2. Now, integration is easy now. Arc length is equal to integral 0 to 2 pi square root of r square plus dr over d theta the whole square d theta. That is equal to 2 times integral 0 to pi, because of the symmetry. See here, these two areas are the same. So 2 times the arc length. If you evaluate it from 0 to 2 pi, you may get a 0, because 1/2 is below the x-axis. So the strategy is you draw the graph. Theta is 4 cos theta over 2, and so this will be the graph, and so the total arc length is 2 times the upper one. The upper one is 0 to pi. So 2 times integral 0 to pi, that is 2 times the length of the upper half. 4 cos theta over 2 d theta. that is 4 2s are 8. Divide 8 times sine theta over 2 divided by 1/2, 0 to pi. 8 divided by 1/2 is 16. So 16 times sine pi over 2 minus sine 0. So 16 times sine pi over 2, which is 1. So that is 16. So the answer is 16. I know some of these problems are not very easy, so please practice as much as possible. Okay.